I'm Professor Kumar and you are at Galaxy Online Learning from Galaxy Tutorials. Okay, name of our channel, Galaxy Online Learning. Please subscribe, press the bell icon, you'll be notified about the lectures being kept for your understanding, easy learning. Please register, collect your assignment books. Okay, the study pack 3 have been issued, 1, 2 and the latest third one is given. In the coming week, study pack 4 and 5 will be issued. So please use them wisely for the question answers, for what will come in the exam, etc. Today we are seeing Science, Chapter 12, second lecture on electricity. In the last lecture, I taught you in the end about resistance. I told you resistance is proportional to the length of the conductor and resistance is inversely proportional to the cross-section area of the conductor. And we had done some problems on it. Today we will go more into resistance and see how to calculate resistance of multiple devices at the same time. So first, we have now studying today system of resistance. So I have system of resistors, more than one resistor system. We have two types of arrangement. One is series arrangement, okay, of resistors, in which the resistors are arranged one after the other in a serial manner. So this is R1, this is R2, this is R3. Okay, my friends? So this is series arrangement. In this, the potential difference, okay, is distributed across. So I have V is IR1, V IR2, IR3. The potential difference V I will write separate. So I have three places where I have by Ohm's law V is equal to IR. If I remove I common, I will get R1 plus R2 plus R3. So potential difference is sum of the resistances multiplied by the current in amperes. This is called series arrangement. Now, in this, there are disadvantages. Number one, if one of the resistor gets spoiled, suppose this one gets spoiled, then the current cannot flow and the circuit will break. So this is seen as series of bulbs you put for decoration, etc. Okay, so they are connected one after the other. Also, when you add resistances become quite high. First one is 5, second one is 10, the third one is 15, total become 30. More the resistance, as you know, my friends, multiply by R, voltage, more will be the power consumed. So this is resistance in series. So this is how we show in the diagram. Second arrangement we have, we'll draw the circuit also. So this will complete the circuit. So this circuit will look like this. Okay, I have an ammeter here to measure. I have a voltmeter across. So I can measure the volt, plus, minus, and again plus, minus. And I have, as I told you yesterday, earlier lecture, we will have battery cells. Okay, and I will put a key in between to switch on and off. This is I, which flows through the circuit. This is plus, this is minus. Okay, so this is how it looks like. And I is the current in the circuit everywhere. Remember the formula, V is I, R1 plus R2 plus R3. Now that is why total resistance in series is R1 plus R2 plus R3, so on. Just go on adding the resistances of the individual. Second we have is parallel arrangement. Resistances arranged in parallel. in this, my friends, looks like this. R1, R2, R3. See the difference? One behind the other, here all simultaneously attached. We'll complete the same circuit from the, because your diagram will be required. So I'll have plus, minus, just show 1 or 2 or 3 batteries, and I will have an ammeter, you will keep it here also, no problem. And I will have a connecting wire back, and I will have plus, minus, current is I will call it point A and point B, through which all 3 resistors are connected, and this is the current I flowing through it. This is how we show. And of course, voltmeter always will be across. Voltmeter always will be across. Ammeter is connected in series, voltmeter is connected across or in parallel. Now in this case, my friends, when you see this, okay, we are having, here we added the individual voltages, voltage here, voltage 2, voltage 3, so get IR1, IR2, IR3, simple. Here we find that in a parallel circuit, when we are solving, we will find that total current is the sum of current. So here, total voltage was individual voltage, through which I got IR1, IR2, IR3, I common, R1, R2, R3, whatever, okay, I wrote outside. Here, the current will break up, will go here, will go here, will go here, the current breaks up. And total current is sum of the 3 currents, 3 channels, which will come out again. Now, V is equal to IR, I is equal to V upon R. So this is V upon R1, V upon R2, V upon R3. V is not divided because the total voltage across all are fitting in that same point A and B. And when I remove common here, I will have 1 upon R1, 1 upon R2, 1 upon R3, and so on. So, resistance in parallel is 1 upon R1, 1 upon R2, 1 upon R3. So, the effective resistance are written like this for the entire circuit, and then you can calculate how much power you are using, etc. We will see sums on these now. Okay? Clear, my friends? Diagram, formula, how we get the formula? Numericals are pretty simple. We will see how to do. We'll do some and it will give us confidence. Okay. Sum number 12.7. 12.7 numerical on page 212. It says, an electric lamp whose resistance is 20 ohms and a conductor of 4 ohms resistance are connected to a 6 volt battery. Diagram is given. We will draw the diagram. Okay. This is how it is. Perfect. And a 4 conductor has got 4 ohms. Bulb lamp has 20 ohms. They are eating up power. Okay, and battery is 6 volts. Okay, calculate A, the total resistance. to find A, total resistance, B, we have to find current through the circuit, and C, we have to find potential difference across lamp and conductor. This is what we have to do in the problem. First, we will write here R1 is 20 ohms, R2 is equal to 4 ohms, two things which are resistors in our circuit. Now they are connected in series. Resistances are in series. Therefore, we have to find total resistance. Resistance total is R1 plus R2 for series. That is 20 plus 4. That is 24 ohms. That is our first answer. Okay. Now, the potential difference given to us, V given to us is 6 volts here, my friend. Okay. Now, Ohm's law, V is equal to IR. Therefore, 6 is I into 24. I is 6 divided by 24. 6 fours are 24. Or you can again divide it by 0.25 amperes. Don't forget the units. Anytime unit goes, half mark will go. Now, my friend, we have to find across the resistor and the lamp separately. Okay. So, across the lamp, first we will see V is equal to 20 ohms into 0.25 amps from here, 20 given for the lamp. So, I will get 5 volt. So, this is across the bulb. Across the conductor, okay, you can write V1. V2 is 4 ohms into 0.25 amp. That is 1 volt. So this is how to find the third part of the answer. Please write the answer separately as it is asked. Otherwise, half mark will go. Answer, total resistance of the circuit is 24 ohms and current through the circuit is 0.25 amperes and potential difference across lamp is 5 volts and across conductor is 1 volt. That is how to do the sum. Okay? Be careful, very nicely, carefully. We will look at one sum for parallel also. .8. Problem number 12.8, page is 214. The book problems are very important. They frequently keep coming in the exam with same numbers. We have more and which have already come and question bank in our study packs. In the circuit given, okay, circuit is given and we are supposed to use the circuit. Okay, we are using circuit. Suppose a resistor R1, R2, R3 have values. R1 is 5 ohms, R2 is 10 ohms, R3 is 30 ohms, battery is 12 volts. Calculate. Find out A, current through each resistor. Each resistor. First, total current and C, total resistors. diagram I'm putting on the board. R1, R2, R3, and then voltmeter across, followed by the other circuit. This is battery. This is the key. This is the ammeter, and we will complete the circuit. Okay, so this is I flowing I. So this is the diagram in which all this is given. Okay, same diagram from theory we are using because they've asked us to use 12.10. So we have to see this. First, we will see current through I'm doing A, R1. I will take one at a time. Okay, I is V upon R1, that is I1. So I will have voltage is 12, resistor is 5 ohms. So you divide, you will get 2.4 amperes. Okay, so first part. Second part, current through R2. I2 is V upon R2, 12 upon 10, 1.2 ampere. Yes, my friends? Current through third resistor, I3 is V upon R3, 12 upon 30. When you divide, 0.4 ampere. This is how we find the first subpart of the answer. Then I'm supposed to find the total resistors. But we can go for total current second. Total current is mathematics, my friend. I think you know how to add I1 plus I2 plus I3, 2.4, 1.2, 0.4. So this will give me 4 amperes is my second answer. Okay, third part, total resistance. Resistance in parallel is 1 upon R1 plus 1 upon R2 plus 1 upon R3. Inverse you add. So this is 1 upon 5, 1 upon 10 and 1 upon 30. That is my total resistance in parallel. When I complete this LCM, I will get 3 ohms. If it was series, you can see it would have been 45, and this is 3. So less resistance, more current flows, less is current used. That is why we connect in home everything in parallel. Okay? And one of them breaks, suppose this breaks, does not make a difference, current still flows to the other circuit. So one appliance gets spoiled, we don't get total shutdown of current flow. So this was next sum. Please have a look. We'll look at another sum. We are doing 12.9 on page number 250 of your textbook. It says in figure 12.12 they have given us a figure. So TK, ammeter A, and resistances R1, R2, R3, R4 and R5, and the points, and they're connected between two common points in parallel. And okay, so this is how we are showing. So current I flows through the circuit. So R1 is 10 ohms, R1 is 10 ohms, R2 is equal to 40 ohms, R3 is equal to 30 ohms, and R4 is equal to 20 ohms, R5 is equal to 60 ohms, has been given, and battery is 12 volts. We are supposed to find a total resistance of the circuit. Number one, and number two, total current flowing in the circuit. So my friends, to make this diagram simple, first you will solve R1 plus R2, so your circuit will have one answer. So this is your first answer, okay? So your first answer will come like this. You will solve this in parallel, you will get another total resistance. Now these are in series. These are in series. So this will be converted to this form. Then only we would be able to solve it. So first, take R1 and R2, solve by parallel formula, find total resistance, that is your RA. Second, take R3, R4, R5, solve it in parallel and get total resistance as in parallel as RB. Now RA and RB are in series, so you will add RA and RB. This is how to do the sum. I've simplified the diagram for you for that purpose. So, number one, okay, we will have first RA is 1 upon R1 plus 1 upon R2. That is 1 upon 10 plus 1 upon 40. Yes, my friends? That will give you 5 upon 40, okay, and which is 5 eighths, and when you invert, remember, this is 1 upon RA, don't forget. Therefore, RA is equal to 8 ohms. Then we'll go for the next one. 1 upon RB is equal to 1 upon R3, 1 upon R4, 1 upon R5. That is 1 upon 20, 1 upon 60, okay, and 1 upon 30, 1 upon 20, and 1 upon 60. So you will add all three, and when you do this, you will get 6 upon 60, okay, or RB is equal to 10 ohms. Okay, therefore, total resistance is RA plus RB as they are in series. So RA is 8 ohms, RB is 10 ohms. So total resistance I get, total I will write now, total is 18 ohms. This is my first answer. Now to calculate the total current, I will use by Ohm's law. V is equal to IR. V is given to me as 12 volts and I don't know. R is 18. I is 12 upon 18. When you divide 6 2s are 12, 6 3s are, you will get 0.67 ampere as your answer. So this is how you should finally, please write the answer in words so that you don't lose half a mark. See how to do sums when multiple circuits are given. Always reduce them to series, which will make life easier. Okay. Then, in the last portion of the chapter, we are looking at heating effect of electric current. How does electric current get converted to heat? How much current will give me how much heat? Joule worked hard on all these experiments. So we will see calorimeter, we will be seeing copper vessels in which we measure temperatures by heating water, etc. So we will have a look at that. Heating effect of. Now he says, consider a current I flowing through a resistor of resistance R and let the potential difference be V. Let T be the time through which you switched on the current, so charge Q flows. So we will just put all these things down. I is the current and R is the resistance, V is the potential difference, T is the time for which the charge Q flows through the circuit. Now, work done, please write full forms for them. Work done in moving the charge Q across potential difference V is V multiplied by Q. Therefore, the source must supply energy equal to V into Q in time T. Otherwise, work will not be done. Therefore, power input is V Q by T. In how much time, how much charge is being transferred, how fast you're transferring the charge. And this is equal to VI, which we have already seen. Okay. Now, for a steady current I, if you keep the current steady, don't make it up, down, we don't keep moving things like geyser or something, we will have heat H is produced. H is the amount of heat produced. So H is equal to VIT, the current, the voltage, and for which time you are passing the current. By Ohm's law, okay, V is equal to IR, IT. V is IR by Ohm's law. So this is I square RT, also in another form. Okay, nothing great, but we can make various forms. And this is how we get the equation. Let us see some problems on the heat produced. Okay. An electric iron. Where are you using heating effect? Geyser, iron, okay, induction at home to cook food. An electric iron consumes energy at the rate of 840 watts, okay, and when heating is at the minimum, voltage is 220 volts. What are the current and resistance in each case? Okay, so we are told 12.10 on page number 217, we are told that the current I is from here, or I will write first there, P is VI. Therefore, I is P upon V by interchanging the sides. Okay. Now, A, when current is maximum, when I would say heating effect is maximum, you put it on full. You go on to the last setting. I is 840 watts divided by 220 volts. Now this will give me 3.82 amperes. And V is equal to IR. Therefore, R is V upon I. Ohm's law. Okay. So, I will get 220 volts I'm having, and I'm having 3.82 amperes as a current. So I will get 57.60 ohms when I divide it patiently. Now, when the heating effect is minimum, you are putting at the minimum value, okay, to heat. Now, I is, okay, he says at maximum it is 360 watts. 360 watts. Maximum 840, minimum 360 is a range over which a heater will work. Then voltage does not change. We will not change anything. So when we divide this, I will get 1.64 ampere. Less current is used in minimum, more current is used. That's why we should not waste heat. We should let it warm gently instead of putting on the full and letting the water spill out. So we should be, or iron also, we should go on medium or low and not put full high and keep it. You see, more current is consumed. Then, and resistance of the circuit, R is V upon I, that is 220 upon 1.64, and this will give me 134.15 ohms when I calculate. So resistance increases. That is what you turn the knob on an iron, silk, cotton, heavy, okay, and you change these readings like that. You don't change the wire, you don't change the current, but the supply will change because you change the resistor. Okay, my friends, easy to do. We will go for the next sum. So all these things which you see, fan speed controller, or in an air conditioner 1, 2, 3, on an iron, silk, cotton, low light, high light, all this is basically changing the resistance in the circuit. Air conditioner, you're changing the temperature. Then 12.11 on page number 217 of your textbook. 100 joules of heat, 100 joules of heat is produced each second, okay, each second. So I have time is 1 second. In a 4 ohm resistance 4 ohms. Find the potential difference across the resistor. Okay, now we have got from our formula H square, H is equal to I square RT. We are just seen before I erase the theory. So I is equal to square root of H upon RT. Okay, put the values. Heat is 100, resistance is 4, time is 1, okay, and you will get 25 square root 5 amperes. Now we already got current. We have to find potential difference. V is equal to IR by Ohm's law. Memorize, and Ohm's law will save you in the exam. Okay, I is 5, resistance is 4, that is 20 volts is the answer. That is how I complete my numericals, and I will get full marks in the exam. Okay, so this is how to do the sums, and this is how to manage. We are coming to the last part, practical applications of heating effect of electric current. First, so I will put some points for you also, so that is easy for you to revise. What are practical applications? Of heating effect of electric current? First, you know very well that we need light. So in the light, you have a nichrome wire which is strung between this. So current flows in, big resistance is there, this gets heat is produced, and this gets heat, and too much heat, it gives you light. That you call a bulb, a light source. Okay. Now, because oxygen will combine in with a heated metal, form an oxide, etc., we put this in a bulb glass container, and we put nitrogen or another inert gas in it, and we keep points ready. Okay, so one of this comes here, one of it comes here. Another is the fuse. Fuse, my friends, you see that is a big piece put in the circuit earlier in your extension box, and in computers we have a small fuse like this in cars with metal ends, and there's a thin wire in it. This is metal, this is glass, and this is a wire. So this is called a fuse. What is special in a fuse? Here you will have inside, which you can't see, a wire. The metal of the wire of the fuse is an alloy with tin. It melts due to heating effect. So when there is too much current, it gets overheated, it melts. When it melts, it breaks the circuit and current stops. So you prevent loss by burning, etc. And your life is safe. Now, fuse have got ratings. The fuse which I use for my computer circuit or mobile phone, and the fuse which I use for electric kettle or a geyser are different. They are rated for different requirements of energy. Okay. Now, for home, we have 1 ampere domestic used at home. Fuse will be 1 ampere, 2 ampere, 3 ampere, 5 ampere, and 10 ampere normally. Okay. For iron at home, that's a bit, you are using 5 ampere because it pulls off more current. That's why the socket is big. It's not 2 pin we normally use for iron because it will burn and melt. Normally 4.54 amperes are used by the iron. So different fuses are there. When you go to the bottom of your building at circuit where you keep on the ground floor, you will see the different sizes of fuse. Now we use MCBs also, so you will see different types of fuses. But basically fuse is an alloy. Now we are using magnetic effect so that they don't melt. We just put them on, and again the magnet will pull. The magnet trips, loses the magnetism, and throws the plate down, and current is broken. So this is the practical application number 1. Major application is the electric you're consuming at home. And everybody is crying nowadays that we have got such big bills, electric bills, because we were all in lockdown, and how come we are having such big bills and all. So this is the issue today. So that is electric power. Your domestic home electric bill. Now, we saw power is VI. We also saw that power is I square R because V is IR by Ohm's law. Okay? And if we substitute otherwise, we can also get V square upon R by putting V upon R instead of I. So these are all the forms we get. Now, the SI unit of power is what? James Watt was a scientist. Watt is named after him. So 1 watt, because we see here, 1 watt is 1 volt into 1 ampere. See friends? So simple. From the formula only you can see that. So, power consumed by a device that carries a current of 1 ampere when operated at a potential difference of 1 volt. Now, every day we are using so much electricity. And if I tell you that you are consuming 3000 what 30,000 watt, you'll laugh at me. So that is why we made a bigger unit called kilowatt. Kilowatt. You divide by 1000 and we have a kilowatt. Okay. 1 kilowatt is 1000 watts. Okay. Now, if we go on measuring watts, we also have to see how much watts you're using for how much time. I may use for 5 minutes, you may use for 5 hours, you may use it for 5 days. It has to be different. So, unit of electric consumption is kilowatt hour. Okay, so this is 1000 watts, okay, into 3600 seconds. This is 3.6 into 10 raised to 6 watt second, and simplified as 3.6 into 10 raised to 6 joules. Joule named after joule. So 1 kilowatt hour. Learn how to convert. Okay, we will be seeing numerical problems on this. 12.12, page number 219 of your textbook. An electric bulb is connected to 220 volt generator. The current is 0.5 or 50 amperes. V is 220 volts. What is the power? Power is V into I. You can see with your eyes. I will bring it here. Power is V into I. V is 220. I is 0.50. Okay. And this is 110 watts. Or I will write W as the unit. Simple, my friends. Let us look at 12.13 on page 219 and 20. An electric refrigerator rated 400 watts. Rating, how much it can use. Operates 8 hours per day. 8 hours per day. Refrigerator. What is the cost of the energy to operate it for 30 days? We are going to use 30 days. Use of 30 days. And I pay rupees 3 per kilowatt hour. So what will be my bill? How much rupees I have to pay? Like this is how it comes to your home. Okay. First, you have to consume total. Your bill comes for the entire month. Doesn't come daily, half a day, when you use. So we have to calculate it for a period. So for 30 days, total energy used for 30 days, okay, is 400 watt into 8 hour per day, okay, 8 hour per day into 30 days. So that is 96000 watt hour. That is divided by 1000. So I will get 96 kilowatt hour. That is what your meter shows when it rotates the reading or numerical reading by LED. Now, total cost for 30 days is, I have used 96 kilowatt hour and I have to pay rupees 3 per kilowatt hour. So I have to pay rupees 288 as my electric bill. That is how to do the sum. Yes, my friends, so simple. Keep track with me, so it will be easy for you. So, what is the power per day? How much you are using? How many days you are using? Divide by 1000 and first find kilowatt hour, because your bill comes in kilowatt hour. Commercial unit. This you multiply by whatever rate is given, and you will get the electric bill. Yes. For more sums on this and more question answers on this, MCQs, objectives, what has come in the past paper, please refer to the study pack. Okay, we will be doing all those and more questions after we first finish basic explanation of the chapters. Okay, kindly register and collect your study packs. By the time you come and collect, your 4 and 5 study packs will be ready. And kindly start solving, which is more important. We are not in a hurry. You can come after the lockdown is lifted. You can start studying after Diwali. We have no problem. The time period, my friends, will become very short. So at that time, when you must practice exams, you will be studying. Now that will set you off. Okay, as it is, times are bad. As it is, patterns are changing. Portion is reducing. This is happening. Everything is fluid. Better be strong. Portion may reduce. Paper may come easy. But next standard, who's going to teach you what was to be learned? If you didn't do 9th, you see how difficult 10th would be. So that is why it's better to learn more. You may sit for lesser exam. Don't be very happy that 30% portion is reduced. Your 30% knowledge is also disappearing. In next standard, you will have to make 130%. 100 for the 11th and 30 from the 10th to understand that. So it's not nice to say portion is reduced. That's a compulsion. We can't do anything. Learning cannot stop. Please start learning when there is time. And subscribe to the Galaxy Online Learning channel and kindly get all the videos. Take a notebook, take a pen and solve step by step as I solve. Okay? Thank you.